Good morning and welcome to Unit 6, Systems of Linear Inequalities. Let's begin. So as a first example, this is a recap of a question you would have done in Foundations 10. Okay? You have the equation negative 3x plus 4y equals 12. And we are asked to graph this equation. So there's a couple different ways you could graph this, right? One way is you can find the x and y intercepts. You can find the y-intercept by making x equals 0, and you can find the x-intercept by making y equals 0, and you can connect those dots. Or you could get it into the slope-intercept form of y equals mx plus b, and then isolate y, and then graph the y-intercept and the slope, and graph it that way, okay? I think I'll do the y equals mx plus b way. So if I were to get, if this were my equation, negative 3x plus 4y equals 12, and I had to graph that, I'd add 3x to both sides, so I get 4y equals 3x plus 12. I divide both sides by 4. I get y equals 3 over 4x plus 3. Okay? If I had to graph that equation, my y-intercept is at 3, 1, 2, 3. So I have a dot there. My slope is 3 over 4, so 1, 2, 3 is my rise. 1, 2, 3, 4 is my run. I'd connect those dots. It's somewhat of a straight line. And that would be my graph, okay? So that's something you would have done in Foundations 10 in Chapter 6, okay? We're going to use those skills, but we are going to deal with linear inequalities, okay? So instead of using an equal sign, we are going to have an inequality, which could be less than, greater than, less than or equal to, or greater than or equal to. And we will get into how that affects your graphs here in just one moment, okay? So here's the steps, and don't feel like you have to write this down right now. We're going to put it into practice in just a minute. But what we're going to do is to graph a linear inequality. You have to start by graphing the linear equation that represents that boundary. So that's just like we did right here. Step 1 is to graph it just like you would have in grade 10, okay? Next, you're going to choose a test point. This point cannot be on the line. If possible, 0, 0 is a good test point. And the purpose of the test point is if the test point makes the inequality hold true, all points on that side of the line would be the solution set. Okay, now that sounds a little confusing. I'm going to give you an example. So let's go back. Let's say we had a line like this, okay? And in a linear inequality, either the points below the line are part of the solution set, or the points above the line are the solution set. Okay, so what you have to do is you're going to have to choose a test point. So like, let's say, for example, your equation was y is less than 1 over 5 x plus 4, negative 1 over 5. Let's say, for example, can you close the door? Thanks. Y is less than or equal to negative 1 over 5x plus 4. And let's say this was our graph. I don't know if this is our graph exactly, but we'll pretend it is. If we had to put a test point in here to see whether the below the line or above the line was the solution set, 0 and 0 is the easiest number to use because that's right here. So let's find out if 0 and 0 is in the solution set. So I put a 0 in for y, and I put a 0 in for x. Well, 1 over 5, negative 1 over 5 times 0 is 0. So what we're left with is 0 is less than or equal to 4. Is that true? Is 0 less than or equal to 4? Yes, it is. So if that's the case, that means that 0 and 0 is in the solution set. So that means if we were to graph this linear inequality, after we get the line, we have to color in below the line, okay? Because all of those numbers below the line are part of the solution set. All of the numbers above the line, like if I picked 10 and 10 up here, that would make this inequality false. So then those numbers are not in the solution set, okay? Now what's going to happen in 6.2 and 6.3 is what you're going to get is you're going to get one graph like that and then another graph like that, and then you're going to have to find the solution sets of both, and you're going to have to find that spot where they overlap. But that's getting ahead of ourselves a little bit, okay? So let's try an example. Let's try this one together. The question says to graph negative 2x plus 5y is less than or equal to 10. Okay? So once again, you can start by finding the x and y intercepts, or you can put it in slope-intercept form. I like the slope-intercept form, but again, either way is fine. So if I want to get the y by itself, I'd add 2x to both sides. So I get 5y is less than or equal to 2x plus 10. I divide both sides by 5, and I'd get y is less than or equal to 2x over 5 plus 2. So now we can graph that line. Well, excuse me, the y-intercept is at 2. 2, right there. The slope is 2x, sorry, the slope is 2 over 5. So a rise of 2, 1, 2, and a run of 5. 1, 2, 3, 4, 5. Now we can connect our lines, or connect our dots, sorry. And now we've graphed it. Now we're only half done, right? Step 1 is to graph. Step 2 is to find the solution set. And that's where we use the test point. Okay? We can use any test point we want on the graph as long as it's not directly on the line. So we can use 0 and 0, as 0 and 0 is below the line. So let's plug in 0 for x and 0 for y. Well, that'll become 0 is less than or equal to 2 times plus 2. Well, 2 over 5 times 0 is 0. We're left with 0 is less than or equal to 2. Is 0 less than or equal to 2? Yes, it is. That means that the solution set is everything below this graph, okay? And you color something in like that. If we put in the solution set and it was false, that would have meant that 0 and 0 was not part of the solution. So that would have meant we would have colored the opposite side of the graph. We would have colored above the line. If the test point is true, you color, in this case, below. If it was wrong, you would have colored the opposite side. All right? Next. When the line is included in the solution set, use a solid line. So like if I'm graphing and I have this, if the line is included, then I would use that. Then I would graph with a solid line. If I had, when the line is not included in the solution set, like if you had this, y is less than 3 without equal to, then you are to use a dashed line, okay? So, just like if you remember when you used to do number lines, right? And you would color in the circle if it was equal to, and then you would not color in the circle if it was not equal to. Same sort of thing. If the if it's not equal to, we use a dashed line. And if it's equal to, we use a solid line. Now, make sure you pay attention to this part. Not all inequalities want to know any number that's above or below the line. Sometimes the inequality is only valid for certain numbers, okay? So like, for example, in our next question, they're going to be using, it's going to be about the number of skis and snowboards that are sold. Can you sell a negative number of skis or snowboards? No, right? So sometimes you're limited to certain parts or certain numbers. So here's what you have to watch for. If they tell you it's real numbers is like negative infinity to positive infinity. That's every number, okay? Fractions, decimals, whatever. Every number is included when you use real numbers. Sometimes they'll do integers. Integers means that it's just positive or negative numbers, but they're whole numbers, okay? Not fractions or decimals. Whole numbers are 0, 1, 2, 3, 4. They're only positive, but they include 0. Natural numbers are 1, 2, 3, and 4. They don't include 0. Now, the main two that we're going to use are real numbers and integers. And I will put this, I'll put this on the test so you don't have to memorize what they're all called. I'll put this little table on the exam so you can remember which is which, okay? But here's how it changes when you're graphing. Well, let's do this one first. This is, and if you need to pause it to write this down, that's fine. A sports store has a net revenue of $100 on every pair of downhill skis sold and $120 on every snowboard sold. The manager's goal is to have a net revenue of more than $600 a day, okay, from the sales of these two items. What combinations of skis and snowboard sales will meet or exceed their daily sales goal? So the first thing we have to do, if you remember any problem-solving question, we have to identify what are those two variables. What are we trying to find? Well, let's say X is skis and Y is snowboards. We'll use X and Y as that's what we're most comfortable with, okay? Now, let's make our equation. So we've got our skis and our snowboards. Well, we know that he makes $100 on every pair of skis, so 100x. Plus, he also makes $120 on every snowboard sold, plus 120y. The goal is to be greater than $600 a day. So greater, not equal to, right? Because he doesn't want to be greater than or equal to. He wants to make more than $600. So 100x plus 120y has to be greater than $600. Okay? So now we've got our equation. Now we have to graph it. Okay? So I'm going to write the equation down again. 100x plus 120y has to be greater than $600. Okay? So let's get the graph it again however you want. Find the x and y intercepts or isolate y. I'll find the x and y intercepts this time. So to find the x-intercept, you make y equals 0. So if I make y equals 0, that's 100x. 0 times 120 would be 0. So x-intercept is 5. Then to find the y-intercept, you make x equals 0. So I put a 0 in for x, that would be 0. I'd have 120. Oh, why did I say that was 5? That should be a 6. I'm sorry. That's bad math. It should be a 6. 120 is greater than, 120y is greater than 600. Divide both sides by 120. I think that's 5. Yep. Y is greater than 5. So our intercepts are at x equals 6. 1, 2, 3, 4, 5, 6. And 5 for the y. 1, 2, 3, 4, 5. And now we just connect our dots. Now, this time it is not equal to, right? It's just greater than. So we're going to use a dashed line. Okay? So now we've graphed it. The next step is to do the solution set, do the test. Okay, so we're going to test with 0 and 0. So if I put 0 in so if my equation is 100x plus 120y is greater than 600, 0 for x and 0 for y, I'm going to get 0 is greater than 600. Is 0 greater than 600? No, it's not. Okay? So if 0 is not greater than 600, that means this point is not in the solution set, so we are actually looking above the line for our answer this time. Now, remember, before I color it in, remember how, so this was false, right? Remember how we talked about, just going to go back for a second, the difference between integers and real numbers? This is sort of a lifelike application of where it would take place. If I colored everything in, that's saying that I could calculate the price of, 6.2 snowboards sold and maybe 7.5 skis sold or something like that. But can I sell 0.2 of a snowboard or 0.5 of a ski? No, I can't, right? So the way this is supposed to be graphed and colored in is if we're just dealing with integers, what you have to do is you have to actually just color in the dots, okay? Because it's not a matter of coloring in the entire thing, because you can't actually measure, a part of a ski or a part of a snowboard. Now, do you have to color in every single dot to get the question right? No. Like, I'm not going to sit here and make you color in every dot. That would take me 15 minutes to get every dot. But if you color in a majority of them, I can see that you understand this is supposed to be above. The final part of the question said, choose two combinations that make sense. Remember, he's looking for the amount of skis and snowboards he could sell for and make more than $600 a day. So we go back here. Remember, X was our skis and Y was our snowboards. So a solution that makes sense is he could sell 1, 2, 3, 4, 5, 6. He could sell 6 skis and 1 snowboard, because this dot right here is in our solution set, right? If he sold 6 skis and 1 snowboard, he would make more than $600 in a day. Or maybe he sells one, let's just pick a dot, like I'll use a different color here. What are the skis and snowboards for this one? Well, that's 1, 2, 3 skis and 1, 2, 3, 4 snowboards. He could also sell 3 skis and 4 snowboards. Now, obviously, you could say, oh, he could sell 1,000 skis and 1,000 snowboards today and he would make his money. That's true, but is that really a realistic solution? No, probably not, right? So if you're asked to pick reasonable solutions that would answer his question, you're just sort of picking numbers that are in here. Don't go crazy picking stuff way off the map, okay? Next. We're gonna skip that one, we'll do this one. So here's what the questions will look like sometimes, okay? And they try to set it up in a way, and then maybe it looks confusing, but here's what we're looking at. We'll do these together. So we'll do this one's yellow, and this one will be green. So let's do A first. A says x minus 2 is greater than 0. That's our equation. X minus 2 is greater than 0. That's what it wants us to graph, okay? And it says XER and YER. Let's talk about that in a minute. Let's graph this first. So if x minus 2 is greater than 0, we get x by itself. X is greater than 2. When x is greater than 2, that makes a horizontal line at 2. It's not equal to, right? So it's just going to be a dashed line at 2. Okay? So we graphed our equation. X is greater than 2. Now we can find the solution set. So we test 0 and 0. We do our test. 0 and 0. We put a 0 in for x. 0 greater than 2. Is 0 greater than 2? No. So that means that the test point 0 and 0 is not part of the solution set. So that means if that's below the line, we are looking to color in above the line. Now, we have to decide whether we're coloring with dots or whether we're coloring the whole thing in. This question says XER and YER. That means that the domain and range, the X and the Y, are real numbers. If it's a R equals you're coloring everything in. Color everything. If it's a Y, that means it's just the integers. I means dots. Okay? So in this case, we graphed our line. We did the test. The test was false. So we are coloring in above the line, like so. And we're done. Okay? For number 2, our equation was negative 3y plus 6 is greater than or equal to negative 6. Okay? So we solve for y, we minus 6 from both sides, we get negative 3y is greater than or equal to negative 12. Now, do you recall, I'm going to actually do this on the next, I'm going to do this on here so you have a little more room. Negative 3y plus 6 is greater than or equal to negative 6. So I minus 6 from both sides, right? I have negative 3y is greater than or equal to negative 12. Now, if you recall from grade 9 math, when you're solving for inequalities, if you divide both sides by a negative number to get the y by itself, when you divide or multiply both sides by a negative number, your inequality sign flips. So this goes from greater than or equal to less than or equal to. So your equation is y is less than or equal to 4. Okay, 4 is at 1, 2, 3, 4. It's y is less than or equal to 4. So it's like a solid line because it says equal to. I can go back and do my test. My test is with 0 and 0. If I put a 0 in for y, I get 0 is less than or equal to 4. Is 0 less than or equal to 4? Yes, it is. So that means we are coloring in 0 and 0 is right here. That was true. So we're going to color in to the left. In this case, it was with integers. So that means we're just doing dots on the intersection of the points, okay? Again, you don't have to hit every single dot. That would take forever. This is not a coloring class. As long as you understand that integers means dots, real numbers means you're coloring in the whole thing, then you should be fine, okay? Here is a sheet. If you need to write down the steps again, you can pause it here and look at it. It lays out everything that we talked about as far as graphing the boundary, doing your test point, and then coloring in above or below. If you want to look at it again in sort of the textbook definitions, it's right there. Okay. Your assignment is the workbook, pages 150 to 153. We are going to do 6.2 and 6.3 tomorrow. And then after that will be our Chapter 6 exam. Thank you. Have a good day.